Okay, so today we are going to be talking about the formation of precipitation and explaining the differences between rain, snow, sleet, and hail. So because cloud droplets are incredibly small, rain droplets, for them to reach the Earth's surface, must become larger. There are two mechanisms that produce precipitation: precipitation from cold clouds and precipitation from warm clouds. The Bergeron process is precipitation from cold clouds. This process states that water droplets in cold clouds remain a liquid even at negative temperatures. Within these clouds are ice crystals, cloud droplets, and water molecules. The ice crystals within the cloud will grow larger at the expense of the water droplet and will result in precipitation. From here, the ice crystal falls as snowflakes, but if it meets higher temperatures, it will fall as rain. The precipitation from warm clouds is known as the collision coalescence process. This process is particularly seen in the tropics. Within these warm clouds, large droplets increase in size as the droplet falls. As it grows in size, velocity and air resistance increases. This causes the rain to flatten. Once the raindrop reaches its maximum size of about 5 millimeters, it breaks into those smaller droplets, and these grow over time. According to our textbook, rain is restricted to drops of water that fall from a cloud and have a diameter of 0.5 millimeters. Rain comes from nimbostratus clouds or cumulonimbus clouds. Drops of water are considered a drizzle in the diameter of less than 0.5 millimeters. Snow is a form of precipitation from ice crystals. The size, shape, and condensation produced in supercooled clouds is determined by the temperature in which they are formed. In these clouds, water vapor is deposited as ice crystals remain frozen until it reaches the Earth's surface. Sleet is a wintertime phenomenon. Sleet forms when raindrops fall through a layer of sub-freezing air. Hail is produced in large cumulonimbus clouds. Within these clouds, frozen ice particles and super cold water coexist. As the hailstones travel through the cloud, a new layer is added to that hailstone. When the hail becomes too large, the hail descends to the Earth's surface. Why is lifting of air important, and what are two processes in which air... Orographic lifting is when air is forced over a mountain. Frontal wedging is when warm air and cold air collide. In these pictures, we can see that this side of the mountain is receiving more precipitation than the other side. And on frontal wedging, we can see the cold air pushing the warm air up. The adiabatic cooling process occurs when air is allowed to expand. Therefore, it cools the air. In the picture shown on the right, we can see a parcel of air. It loses temperature by 10 degrees Celsius per 1,000 meter going up. We can see pressure is decreasing, therefore we're losing temperature, or decreasing in temperature. When we reach our dew point, where condensation begins and we see cloud formation, the parcel of air is now decreasing in temperature by 5 degrees Celsius per 1,000 meters. These two zones seen on the graph are wet adiabatic rate and dry adiabatic rate. The wet adiabatic rate is less than the dry adiabatic rate, and clouds are formed at the condensation level.